This picture shows the field lines due to a solenoid. So first we have to discuss what is solenoid. Solenoid is a copper wire. It's coiled in the shape of a cylinder very closely of many turns. And now one end of the solenoid is connected to positive terminal of the battery. The other end of the solenoid is connected to the negative terminal of the battery. Now when the key is closed and if you pour some iron filings, they will be aligned like this. In fact, it looks like the magnetic field lines pattern of a bar magnet. The one end of solenoid is acting like south pole, the other end of the solenoid is acting like north pole. If you observe the pattern of the field lines, here also it is coming from north and they are terminated at the south outside the solenoid, but inside the solenoid they are south to north. The same pattern is observed in the case of a bar magnet. There are some differences between this solenoid and bar magnet. Solenoid, you can increase and decrease the strength of the magnet. By sending large amount of current, you can increase the strength of the magnetic strength, and by sending small amount of current, the magnetic field established by it will be smaller, rather lower. That is one difference. Whereas bar magnetic strength cannot be increased or decreased. That's first difference. Second difference is that bar magnet at the ends, the pole strength is very high when compared to the middle. In fact, if you pour the iron dust at the middle, almost there will be no attraction between the magnet and iron dust. But it is just reversed in the case of solenoid. Inside the solenoid, maximum strength will be there. At the same time, at the center, the solenoid will have larger magnetic strength. In higher classes, you will be coming to know how to calculate the field inside the solenoid. Now you can simply compare a solenoid with a bar magnet. Now let us see the solenoid. As defined, solenoid, a coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder. So here this is insulated copper wire and this is wrapped in the form of a cylinder with many turns very close to each other. So this is a solenoid. Now you can see that this is another solenoid. So here the number of turns are very high and the copper coil is wrapped in the form of a cylinder. And here, if you observe, there are two terminals. So here you can connect the battery positive and negative, then it acts like a magnet. This is another solenoid. Now we will see many number of solenoids of very large size. In fact, the video which I would like to show you is recorded 20 years back. My professor, Mr. Lal Cheddane, who has conducted many experiments with regards to solenoid. So let's go through those videos, and in that he has measured the magnetic field inside the solenoid also. For that he has used one Gauss meter. Now we are going to see the Gauss meter and solenoid of different sizes, and thereafter we will see the field pattern of the solenoid by sprinkling the iron filings. First let us see the video which was recorded 20 to 25 years back. You can see me in that video in a very different way. So this is the digital Gauss meter through which you can measure the magnetic field. Here one probe will be there, and if you keep the probe inside that particular magnetic field, then you can see what is the record that is obtained here. It indicates in terms of Gauss. Remember, we have already given the units, SI units of magnetic field as Tesla. Now Gauss is also another unit of magnetic field. Now in this video, my professor has measured the magnetic field inside the solenoids. You are going to see the solenoids of very thin and it goes up to large radius. Now let's watch this. You are observing that he has kept the probe in between two electromagnets. Now he is observing the magnetic field inside. This is also a solenoid, very thin solenoid he has taken in his hands, and there are some holes in it, and then he is inserting the probe into the holes and finding out the reading through the Gauss meter. Now he has taken another solenoid, that is another one, and here it is the very biggest solenoid. We have seen already a solenoid. Like the same solenoid, it is connected here, and now the current will be passed through the solenoid. So here these are the terminals, and now iron filings are poured. So in the absence of current, if it is trapped, nothing, no pattern is existing. But when the current is there in the wire, now you can observe the pattern.